All right, good evening, everybody. Today we're going to be making comparative inferences about the population. In our first example, we see that Ella surveys a random sample of 20 seventh graders about the number of siblings they have. The table shows the results of her survey. She labeled each one of the students with a letter from the alphabet, and then she put the number of siblings they had underneath them. It says model with math. Draw a model to show how Ella can best display her data. Well, in this case, they're going to use a box plot. In earlier math classes, you might have learned about box and whiskers. And the important thing to remember is that the information is split into what they call quartiles. We have outer quartiles and inner quartiles. The inner quartiles are the quarter of the information that is closest to the middle, and the outer quartiles are the quarter of the information that's away from the median. The median is set in the center, which can be represented by the line in the middle of the box. When I say quartile, you must think of the word quart, which is what quartile begins with. And when you think of quart, you might think of a quart of milk, which is 1/4 of a gallon. And that's what this means. We're taking 1/4 of the data and splitting it up here, splitting it here, splitting it here, and then splitting it here. So since there's 20 students, we're going to take the 20 lowest numbers first. So we got 1, 2, 3, 4, 5. So the first quartile is going to go to the number 1. We know that because there's another number 1 over here, which means that quartile and this quartile are going to meet at number 1. Next, we're going to go to the next 5 numbers, 1, 2, 3, 4, and 5. That means that quartile is going to end right there at 1. Now, you might be confused saying, well, why isn't it ending at 1.5? And that's because after the number 1 is the number 2. And that means the the second quartile is going to end at 1, and then the next quartile is going to begin at 2. So we have to find the middle of 1 and 2, which is 1.5. Now we're going to start with our number 2. Again, we need 5 for the next quartile. 1, 2, 3, 4, 5. That means that quartile will end at 2 because it's another 2 after it, and the average of 2 and 2 is 2. So now we're going to start with the last quartile, which will start at 2, and that's 1. Now we're looking for the number 3, 2, 3, 4, and then the number 6. And that means that range will go from 2 all the way to 6. Explain why you chose that model. Well, that's because a box plot is a good visual representation to use at a glance that the number of siblings are concentrated between 1 and 2, and that the range of siblings is from 0 to 6. Using your data display, you can infer about the number of siblings that most 7th graders have. Most 7th graders have either 1 or 2 siblings. The data in my model are clustered at 1 and 2. Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their school and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? And I'm glad they put this in order. It keeps me from having to jump around this time. Well, the data of the two data sets, or excuse me, the display, the two data sets in box plots. And you can see here that the box is between 3.5 and 6.5, and the median is 5. So why is it set at 3.5? Well, let's find out. Remember, there are 20 students. Again, we're talking quartiles, so we have to take the first 5. 1, 2, 3, 4, 5, which means our first group ends at 3, and the next group starts at 4. So in between 3 and 4 will be 3.5. Now we're going to go to the next group of 5. 1, 2, 3, 4, 5. and that's at 5, and the next one's 5. So that means our median is going to be set right at 5. And let's see, now we're going to go ahead and go to the next 5, which would be 1, 2, 3, 4, 5. And that's going to be at 6, but the next quartile starts at 7, so that means we must go at 6.5 to find where the next quartile would begin. And then from 7 to 11 will be the last quarter of our information for Finn's data set. Now Jones' data set said a little differently, 1, 2, 3, 4, 5. But again, this is 6, so between 5 and 6 will be 5.5. And then 1, 2, 3, 4, 5, and again, between 6 and 8, that's going to put our median at, well, the average of 6 and 8 will be 7. And then we start 1, 2, 3, 4, 5, and since the next one's going to be 8, that means that will be sitting right at 8. And then the last will be from 8 to 11. We can use the box plot to compare the two data sets. The line for the median of Jonah's data set is to the right of the line of the median of Finn's data set. Jonah's data set median is to the right of Finn's data set. So Finn can say that the median of Jonah's data set is greater. We can also say the box for Finn's data set is longer than the box for Jonah's data set. Well, this box is set for 3.5 to 6.5, and that's a difference of 3. But Jonah's data set is set for 5.5 to 8, and that's only a difference of 2.5. So Finn can say that his data is spread out, is more spread out, or has a greater variability, has greater variability. All right. Now we're just making inferences about all this stuff. And remember, an inference is nothing more than some type of information you can pull from the data. Let's look at this example. Kono gathers the height of a random sample of 6th graders and 7th graders and displays the data in box plots. What can you say about the two data sets? Well, one, it says the median of blank grade sample is greater than the median of the other grade. Well, as we can see, the median of the 7th graders is greater than the 6th graders. Next, it says the blank grade sample has greater variability. Well, which one is longer? Well, it's easy to see that the box of the 7th graders is the longer, so the 7th grade sample has greater variability. What does this really mean in the end? Well, it means that from the information he pulled, the 7th graders were between 56 inches and 69 inches, but the average 6th grader was only about 62 inches. The 7th graders that he checked on, some of them were as short as 53 inches and as tall as 72 inches, and that the average 7th grader was sitting at about 63 inches. How can you visually compare data from two samples that are displayed in box plots? Well, you can compare the medians, remember that middle part that shows kind of what the average is, and where the boxes are relative to each other. Well, this box is relatively more to the left than this box, which means we have more 7th graders that are going to be taller than 6th graders, as well as their interquartile range. The interquartile ranges can be found by seeing where each quarter of the information is set. Example 2, it says Finn and Jonah analyzed the measures of center and variability of the data they collected. Do these measures support Finn's assessment of the two data sets in example 1? When we look here, we see that the first quartile was at 3.5 for Finn, the median was at 5, and the third quartile was at 6.5. Now, to find the interquartile range, we have to take the third quartile and subtract it from the first quartile. So that would be 6.5 minus 3.5, which would make 3. We can also go ahead and do this at Jonah's data set, which would be 8 minus 5.5, which would make 2.5. The median of Jonah's data set is greater. So the students at Jonah's school generally spend more hours on homework each week than the students at Finn School. Lastly, we can say the interquartile range at Finn's data set is greater. So there's a greater variability or spread in the number of hours students in Finn School spend on homework. And example number 3, it says Mr. Bunsen has students grow the same type of plant in 2 different rooms and test the growing conditions. The box plot shows the height of all the plants after 3 weeks. How do the 2 populations compare? What inferences can you draw? Well, first we can say that the median heights are the same. They're both sitting at about 12. We can also say 50% of the plants in 7D are between 8 and 14 inches tall. The interquartile range is 6 because 14 minus 8 is 6. 50% of the plants in 7G are between 10 and 6 inches tall. Sorry, 16 inches tall. And 16 minus 10 will give us 6, so the interquartile range is 6. While the median height of the plants are the same, the plants in room 7G are generally taller. You can infer that the growing conditions in room 7G are more favorable for plants' growth than room 7D. A local recreation center offers a drop-in exercise class in the morning and in the evening. The attendance data for each class over the first month is shown in the box plot at the right. What can you infer about the class attendance? Well, we can infer that more people prefer to drop in to the evening class than the morning class. The median is set higher, and the interquartile ranges seem to be set between 5 and 8 in the evening class, where they're only between 3 and 6 in the morning class. Well, we're going on to concepts, keys and concepts, and it says you can use the data displays such as box plots to make informal comparative inferences about 2 populations. You can compare the shapes of the data display or the measures of center and variability. The medians of the 2 data set appear to be the same. 50% of the value in data set A are between 4 and 7. Over here you can say that the length of the box, the interquartile range for data set B is greater than the length of the box of the interquartile range for set A. So the data set B has greater variability. 50% of the value in data set B are between 4 and 9. Well, it's time for us to do the do you understand? First one, how can data displays be used to compare populations? Well, here it says data displays can be used to make inferences about 2 populations. You can use the shapes of the data display or measures of center and variability to compare data sets. What measures of variability are used when comparing box plots? What do these measures tell you? Well, as we've seen, the range and interquartile range are used when comparing box plots. The range and interquartile range describe the variability or speed of the data. And it says 2 data sets both have a median value of 12.5. Data set A has an interquartile range of 4, and data set B has an interquartile range of 2. How do the box plots for the 2 data sets compare? Well, the box plot for data set A is longer than the box in the box plot for data set B. Remember, data set A said that the median value was 12.5 and has an interquartile range of 4. Data set B's interquartile range is only 2. That means there was a bigger spread for data set A than there was for B. Next it says, the box plot describes the height of flowers selected randomly from the 2 gardens. Use the box plots to answer 4 and 5. Well, find the median of each sample. Well, the median for Y is going to be 6. And the median for Z is going to be 4. Remember, it's the center line in the box of the box plot. Make a comparative inference about the flowers in the 2 gardens. Well, that's pretty easy. The flowers in garden Y are generally taller than the flowers in garden Z. Next, we're going to practice some problem solving, and that's your homework. So I'm stopping the video here since the lesson's ended. Please try to do your homework as best you can. And remember to watch the homework video in order to get the answers so you can turn them in and get your grade. Have a great night.